All right, last thing for section 6.2 is we're going to do a pair of problems solving exponential equations in which I can make the bases equivalent. So for instance, I have 25 to the x is equal to 125. So when you're given one of these problems and you're going through your homework, step one is to think, what base do 25 and 125 have in common? Okay, how can I rewrite them as the power of something? And so in this case, that is going to be 5. Use your calculator if you need to. 125 is 5 times 5 times 5, so it is 5 to the third power. And 25 is 5 to the second power, and then I'm raising it to the x. So one of the properties of exponents to keep in mind is when you have a power raised right to another power, you multiply the exponents. So this is 5 to the 2x is equal to 5 to the third. And what you're going to take advantage of is if you look back at those graphs of the exponentials that we just did, and you do your horizontal line test, you notice that both of those graphs we did and all of the transformations are 1 to 1. And so what that means is if I have the same y value, if I have the same output of this exponential function, that means the input has to be the same. And what that means here is that the exponents have to be the same. So that means 2 to the x equals 3. And the reason that I can make this step is because it's 1 to 1. Okay. Same y value means same x value. I divide both sides by 2, and I get that the solution to this is 3/2. You can check that if you want. You don't have to worry about domain because you can plug anything into the exponential. And so here's my set, squiggly, 3/2. That's my answer. And so how we're going to end this video is with one more problem. This is going to be number 50 from your book. Okay, so number 50, it's the same sort of thing, but maybe a little bit more difficult because I don't want you to think that you're going to have all the fun. I want to have some fun too today. So this is number 50 from our book. It says that we have 1/2 raised to the 3x minus 6 power, and that's going to be equal to 8 to the x plus 1 power. So as I'm setting my book down, notice what is the base that I can rewrite both 2 and 8 as? Well, or excuse me, not 2, 1/2. I gave away the answer. Spoilers, sorry everybody. Let me try again. Don't rewind. What is the base I can write both 1/2 and 8 as? Well, you know, it's going to be 2. So I'm going to rewrite both of those. I'm going to ignore the power for a minute. So 1 over 2, the way that I would get the 2 in the denominator is having a 2 to the negative 1 power. That tells me to put the base in the denominator and get 1/2. And then I'm going to raise it to the 3x minus 6. And then 8 is 2 to the third. So 8 is 2 to the third. And then I raise that to the x plus 1. So as you're going through your homework, the whole job that you have when you're solving these equations is figuring out what base you can use to write both of these expressions in. Now the rest of this, hopefully you have the skills to do. When I have a power raised to a power, I multiply. So this is 2 to the negative 3x, and then negative 1 times negative 6 is plus 6. And then 2 to the 3 times x, and then 3 times 1 is 3. I will remind you of the same thing I do so often. Do not forget to distribute. Most common mistakes students make when they do a problem like this. Again, because this is an exponential function and it's 1 to 1, if these two sides are going to be equal, that means the powers have to be equal. So I can not worry about the bases. And so now, did I do something wrong here? No, I think we're good. So now what I'm going to do is I'm going to add this 3x over to that side and get 6x. I'm going to subtract that 3 from this side and get 3. When I divide both sides, I get 3 over 6, which is 1/2. Don't forget to reduce those fractions. And so what I have is the set with 1/2 in it. That's how you solve an exponential equation when you have the ability to make the bases the same.